In this section, we are going to discuss the differences between feature selection versus feature extraction. And this techniques, as you all know, is used in dimensionality reduction, which will actually helps us to reduce the number of features or to extract some important features from the older features that we already have. Now, before we go ahead and understand about this, we really need to understand why should we perform dimensionality reduction. So here I'm going to note down some important points, and this can also be an interview question. The foremost reason is to prevent the curse of dimensionality. Prevent curse of dimensionality. So that is the reason why we specifically use dimensionality reduction. Coming to the second point over here is that to improve the performance of the model. To improve the performance of the model. Now just imagine, guys, in your data set, if you have 100 features, that basically means 100 dimensions are there. Obviously, to train the model, right? Because in every model, when the training happens, some mathematical equation is already present over there, right? So those mathematical equation gets applied to all the 100 dimensions, right? So because of that, it may take more time for training of the model. So basically, to improve the performance of the model, we can also use dimensionality reduction. The last point that we are going to discuss is super important, to visualize the data. And at the end of the day, once we are able to visualize, we will also be able to understand the data. Now you may be thinking what exactly this is. Guys, we human being, we can, at the max, we can see in a 3-dimension way. We can visualize anything in 3-dimension, right? That is in 3D. You can also visualize in 2D, right? We cannot visualize 4D or any dimension that are higher than 3D, right? Suppose if in my data set I have 100 dimensions, obviously I cannot visualize this. So in order to understand this data, what I can do, I can reduce the number of dimensions to 3D or 2D, and I can also see this particular information clearly in front of my eyes so that we will be able to understand the data, right? So if in any interview question, if someone asks you, why do you specifically use dimensionality reduction? You should definitely talk about these 3 points. One is curse of dimensionality, which I have already explained. Improve the performance of the model, right? Visualize the data. If you really want to visualize that data in 2D, 3D or 1D mode, you can definitely use dimensionality reduction. And the major aim is basically to understand the data. Now let's go ahead and discuss about feature selection. Okay. So this feature selection is a process wherein it will help us to select the most important feature, which will actually help us to predict the output. Okay. Now, in order to understand the feature selection process, let's consider that I have a feature which is called as X and I have a feature that is called as Y. Now, let's say I have some data points over here, something like this. Now, with respect to this, if I say when my X value is increasing, my Y value is increasing. And if my X value is decreasing, my Y value is decreasing. So here I can definitely say there is some kind of relationship, right? In this particular scenario. That is, when the X is increasing, Y is increasing, and when the X is decreasing, Y is decreasing. Similarly, I can have one more relationship wherein when my X is decreasing, my Y is increasing, and when my X is increasing, my Y is decreasing, right? So this is also another relationship that I can have between X and Y. And in this particular case, let's consider X is my input feature and Y is my output feature, right? With respect to X, I need to predict what is Y. Now, whenever I have this kind of relationship, then here you'll be able to see if I plot with respect to X and Y axis, here you'll be able to see all the data points will be in a linear relationship, right? When it is in a linear relationship, then it will probably follow this particular approach where X is increasing, Y is increasing, and X is decreasing, Y is increasing. And that is true in this particular case. When X is increasing, Y is increasing, right? Now, similarly, in this particular case, if I probably want to draw a scatter plot, my scatter plot will look something like this with respect to X and Y, right? Now, if I probably try to see this, all the points will be in this inverse relationship. Now, whenever we have in this inverse linear relationship, then you will be able to see that it will follow this specific approach. In this particular case, it will follow this specific approach. Now, obviously, you know that when you have this kind of linear relationship, then definitely X value will be very helpful in finding out the y output. And mathematically, we can also find out a way to quantify this relationship. And the technique that we specifically use in this is something called as covariance. Okay. So here, if I really want to find out the formula between covariance of x comma y, the formula that is used is summation of I is equal to 1 to n x minus x bar multiplied by y minus y bar divided by, and here I'll write x of I, y of I, divided by n minus 1, since we are doing it for sample data. That is the reason we use n minus 1. Now in this particular case, let's say if we are going to get a positive value. If it comes as a positive value, that basically means we are going to follow this specific relationship. If it comes as a negative value, then we are going to follow this specific relationship. So for this, whenever we get negative, we are going to follow this. Whenever we get positive, we are going to follow this. That basically means the relationship between x and y will have this kind of relationship, that is the linear relationship, when my covariance is positive. When my covariance is negative, it will follow inverse linear relationship. And along with that, let's say if my covariance is approximately equal to 0, that basically means there is no relationship between x and y. No relationship between x and y. No relationship between x and y. So if I try to plot this in this kind of scattered plot with respect to x and y, I will be just getting a scattered plot which may be in circular way. And here you can not definitely find out the relationship between x and y. That basically means when x is increasing, whether y is increasing or not, or whether y is increasing or y is decreasing, whether x is increasing or not, right? So whichever have this kind of highly positive covariance, highly positive relationship, which we basically calculate through covariance, we can definitely say that those features are super important features, right? So in this particular case, I can definitely say that if I get a covariance as positive, I can definitely say x is a super important feature and it will definitely be helpful in predicting y. But if I get the covariance between x and y as 0, I'll definitely say that there is no much relationship between x and y, right? So I can definitely remove this specific feature also, right? Now let's understand, along with covariance, there is also a technique which is called as correlation. And we basically say it as Pearson correlation. And Pearson correlation can be given as a formula of covariance of x comma y multiplied by standard deviation of x multiplied by standard deviation of y. Now with the help of this, your correlation will be ranging between -1 to +1. In this case, there is no such range. It can be any positive value, it can be any negative value. But with the help of Pearson correlation coefficient, you will be getting your value between -1 to +1. The more the value towards +1, now understand, this is a super important point. The more towards the value of +1, the more positive correlation it is. The more positive correlated it is. X and Y is, okay? And the more the value towards -1, more negatively correlated it is, right? Some same thing gets applied to -1, right? More negative correlated it is. And similarly, if my correlation between x and y is near to 0, that basically means no relationship. Okay. Now this was an idea to talk about the relationship between x and y. Now how this particular process is basically used in feature selection. This is just one of the technique, guys. There are other techniques also in feature selection, but I just really want to give you a brief idea before we go ahead and understand PCA. Okay. Let's say I have a specific data set. And let's say this is my housing data set. In this data set, let's say I have features like house size. The other feature that I have is something called as fountain size. Let's say that these houses are present within an apartment, and we are also going to take this as a property to predict the price of the house. Now, in this case, these are my independent features. And this is my output or dependent feature. So that basically means I'm going to use this two independent feature to predict the output feature. And obviously when this value changes, this is also going to change. Now guys, if you just apply common sense, you know that fountain size may not be a very important feature, because obviously even though you have a bigger fountain, a smaller fountain, it does not mean that your house price will increase within an apartments, right? Within a number of apartments, right? And obviously most of the bigger apartments, group of apartments will definitely have some kind of fountain and all, right? Just to showcase, just to put some nice showcase, this fountain is basically used, right? Now, if I go ahead and take each and every feature, let's say one of the feature I have taken house size and I have plotted along with the price house. And let's say if I have found out this linear relationship, definitely this indicates that this house size is an important parameter to determine the price, because it has this linear relationship. And how do you calculate the linear relationship, or how do you quantify the relationship between house size and price? You can definitely use something like covariance. And obviously you will either get a very high positive value, or for some other use cases, you may also get some negative value. Okay. Or you can also apply correlation. That basically means you'll be getting your value between -1 to +1. Now in this particular case, definitely you can say house size is an important property, and obviously important attribute, and just by common sense also you can come to the conclusion. Now what about the feature, that is, if I try to plot this feature, that is fountain size and probably price of the house. Now in this particular case, let's say my plotting happens like this, and let's say that this is not at all that much important, right? Now here you can clearly see that there is no relationship between fountain size and price of the house. You can see that, or here you can definitely see that even though the fountain size is increasing, the price of the house is stagnant almost within this specific region, right? So definitely we can come to a conclusion that the relationship between fountain size and price of the house will be very, very less, or it will be approximately equal to 0. Or let's say it is ranging between 0 to 0.25. Okay. Not bad, not that positively or negatively correlated, right? So in this particular case, what you can do is that you can consider that fountain size is not that important feature, and you can drop this feature. Now these steps that we have performed, we are basically saying this as a feature selection process. And here you can also make sure that you can apply covariance and find out how a correlation, and find out like what is the relationship between this fountain size and price of the house. So this is how you can come to a conclusion whether fountain size is important or not, and based on that you can basically drop it, right? And this is what we usually do in the feature selection process. We use correlation and covariance to do it. Okay. Now let's go ahead and discuss. I hope everybody got an idea about feature selection. Now what we are going to do is that we are going to discuss about an important topic, which is the next topic, which is called as feature extraction. Now what does exactly happen in feature extraction? In feature extraction, let's say I have features like x1, x2, and let's consider the same housing example. Now let's say I have something like house size, and let's say I have like number of rooms, and finally I have something called as price of the house. Now in this particular case, you want to reduce your number of features from 2 to 1. That is what we are doing, right? We are in dimensionality reduction. Let's say that I want to reduce my 2 features into 1 feature. That is what we do. Now in this scenario, you know that obviously, or let's say instead of house size, I'll just write room size. Okay, room size. Now here I really want to perform some dimensionality reduction, wherein from 2 features I want to convert this into 1 feature. So obviously I cannot use feature selection. Why? Because both these features are super important in predicting the output, that is your price. Both these features are super important, right? These are my independent feature. And if I also try to find out the correlation or covariance between my input and the dependent feature, here you'll always be able to find out either very high positively correlated or high negatively correlated. We'll be able to find that out. And it is a common sense question, guys. This is obviously going to have a linear relationship with respect to this specific feature. On the top, we basically had fountain size, and I just tried to show you an example by plotting it. It did not have a linear correlation. Now in this particular case, I obviously cannot drop one of the feature and just consider one feature, because here we can definitely see that there is some relationship between the independent and the dependent feature. So in this case, what do? In this case, we perform something called as feature extraction. Now in feature extraction, the core idea is that we take this two independent feature, we apply some transformation, to extract new feature. And let's say this new feature is something called as house size. I'm just giving as an example. And my output feature is something called as price. Now, instead of using this two feature, that is room size and number of rooms, if I also get to know the information of the house size, then also I will be able to predict the price. So in short, from these two features, I am trying to derive a new feature or extract a new feature, which is called as house size. Now just imagine for a domain expertise, if domain expertise is given with these two fields, room size and number of rooms, he or she will definitely be able to predict or tell you the price. Now, instead of giving these two features, if we just give one feature to the domain expertise, then obviously he or she will also be able to predict the price with some difference, right? With some difference. Obviously, some amount of information is lost over here, but again, domain expertise will also get some clear idea about, like, with the help of house size also, he or she can definitely predict the price. So in feature extraction, what we are doing is that we are trying to extract a new feature from the feature that is already present. Okay. And this is how we basically reduce the number of features or dimensions. Okay. Usually here, the example that I have taken only two independent features, but guys, in a real world scenario, you'll be having 10 to 15 features, and we'll try to reduce it to 2 to 3 features. Okay. Now, once I reduce this, I'll obviously be able to visualize it in a proper way. I'll be able to see it, and I'll be also able to understand the data. Now, this is the idea behind feature selection versus feature extraction. So in this video, I've covered so many things. First of all, why dimensionality reduction? Then why feature selection? What is feature selection? What is covariance? What is Pearson correlation? There's also another correlation which is called as Spearman rank correlation. Then we have taken an example with respect to dataset housing. Then I showed you that how we can go ahead with feature selection and how do we come up with feature extraction. Some transformation will happen. What kind of transformation will happen? What is the idea behind or geometric intuition behind PCA? We'll discuss that in the next video. Okay. So yes, in the next section, we'll discuss about this.